computer. Here we go. All right, we are now recording. Here. Solid principles. This is important to OOP. It's both C# and Java care about it. So anybody with the OOP language cares about it. So in software engineering, SOLID is a mnemonic acronym for 5 design principles. And these are something we're going to slowly start integrating into our system. So I do think that this is something I'm going to start. I do want to look for in your next project. I'm not going to hold it against you per se. So it's not going to cause you to fail a project if you don't participate in these and don't push these yet. But it's something we want to start considering as we write our code and as we write methods. We want to start thinking about this stuff and having it in our mind right now. Mostly just because this is a huge item people will bring up during interviews. Some people will mention it, some people will ask about it. So just having this term of art ready is key. Yeah, and so the 5 design principles tend to make software design more understandable, flexible, and maintainable. And so those 3 are very, very useful, right? Those are very, very important stuff to development, right? You know, this one's a huge one. We want people to be able to read our code. We have another system in place for that called clean code itself. So we have a whole principle on making code understandable in its own sense. So everything's going to include that. Flexible, we've talked about. That's one of the key principles of OOP, is making sure that the code is reusable in other places. We can bring it from one place to another, that it can change quickly, that can update, that can be modified fairly easily. And maintainable. And so this one's a key one as well, making sure that we can easily update things or change things if we need to. So if we want to change how our program behaves in a certain scenario, instead of having to scan through 20 to 50 lines of code to find the part in that block that does a certain thing, we go to the method that has titleized that action or that part of the program. And that helps us to be able to maintain the program easier. The principles are a subset of many principles promoted by American software engineering instructor Robert C. Martin, introduced in 2000, design principles and design patterns. So, single responsibility principle. I want to do something quick. You guys are probably already reading it, but you know what? Fun. Let's try this. Oh, no, that didn't work. Yeah, here we go. To do that. Based on just the word alone, single responsibility principle. If you already read it, that's not much you can do about it. But if you have it up on your screen, then stop cheating. Don't look at it. Based on just the term itself, single responsibility principle, what does that sound like it would mean?
Something that has one task to do and doesn't have to worry about anything else. Good.
Any other ways that anyone else want to vouch their opinion on it? Is that I always try to give more than one. Yeah.
If it's dealing with the class, that means the class should only handle one area of action, like say starting the engine is a class, and it should only deal with starting the engine. It shouldn't deal with, you know, driving or anything else. It should only be singularly focused
on itself.
So that way, on itself, yes. So that way, okay, you know, you can easily identify what each class does, and add on or take away as need be when troubleshooting or expanding code.
Right. And that reduces coupling too, right?
We'll get on that later. Yep, that's another one that's in here. So coupling is related to one of these. But yeah, anybody else want to put in their own words on this? What they think it means? At least 3, I think. And again, this is not, I don't expect any of you to know this or be accurate on it. So just you taking a educated guess and having your hypothesis on what this is. Again, you're all computer scientists. Everything you do, anything you code, you should always have a hypothesis of what the result is going to be and what it is. So any other guesses?
I know a little bit about this already, but I would say that yes, classes and methods should only be doing one thing. It shouldn't be doing multiple things.
So let me go ahead and do this. Actually, there we go. There should never be more than one reason for a class to change. In other words, the class should only have one responsibility. And that's classes and methods, 100%. So a lot of you guys, like I will say, David, good for focusing on the class, but it definitely has been applied to both the class itself, but also the methods as well. And that's really one of those things that's kind of expanded on it. People have expanded by taking this from, it was originally designed for just the classes, but now that's expanded in saying that it's also the methods themselves. The methods, each method should have a single responsibility of what it's designed to do. So I guess my first question is the play method from your high-low game following the single responsibility principle?
No,
Not at all, right? It's doing several things, isn't it?
that's one thing. It's the play.
Yeah, one game, one thing, playing the game.
True, but to play the game, it's also doing a bunch of tasks in order to play the game. Now, what the play method could be is just a method calling thing that controls the flow of the game. And so its whole task is to be like, I'm going to call each method in turn one by one to make sure that the play goes the way it's supposed to go. But it's not going to actually do any of the actions that the game requires. That's kind of an idea behind that. So its one responsibility is to control the order of the game. Then every method inside of it is going to do its own task. That makes sense? All right, next one we got. The open-closed principle. Any guesses on that? That one's a little more tricky.
Thinking it has something to do with abstraction.
Ah, that sounds abstract, doesn't
Could be
it?
scalable.
Scalable, okay.
I would say with user input, how you're always talking about how this malignant actor could go in and modify your code and to avoid
Alright.
ways of that.
Okay. Any other evaluations or ideas?
Yes, you should be able to, like, for example, if you list your functions and what they do, a person should be able to come along and override them and add on to those functions if they need to in the future. Like, for example, you have engine is a function, or just say, for example, is the class or a function, and they could upgrade it. Like, and you're only able to do gas, but now you're able to add diesel. Now you're able to add. So it's different types of engines and how they function, but based off of your engine class without actually looking at your code. So in other words, with documentation for your code, they should be able to override and add, like we do, like add another variable or another piece of the function to the class. Or if it is a function that you're overriding, then you should be able to, take what it does and add a little bit more. But keeping in mind that it should only be doing one single thing, which is the same thing, because who knows, like in the future, we went from candles to electricity, so that function should be able to change.
All good.
Isn't that
one thing?
Isn't that the reason that we have setters and getters?
Good,
Yes.
good idea. Good idea. I will say one thing, like David. On one hand, I appreciate the length you go into stuff, but I want to remind you of one quick thing for interviews. Pithy and Albert Einstein's quote: "If you can't explain something simply, you do not understand it." And so for the class, it's great for you to explain. So that's why I don't stop you. But during the interview, you're talking to someone who knows this stuff. So you're not trying to teach them this. You're just trying to show them that you know it. And be aware. Look how short it was here. They were able to word it very shortly. So you want to practice that sometimes. So start with the 50 and then let me ask if I want you to expand on it.
Okay, yeah, I'll do that next time.
Cool.
Gotcha.
I always love the in depth you go, but I want to make sure you don't do that in the interview because that's gonna bite you in the ass. So
trust me.
Software entities should be open for extension, but closed for modification. And so the idea here is that once you've built something, other things should be able to use it, but they should be able to modify it indirectly. Now, what's true, what David said is, yes, if you give this to someone and they want to modify it, they can, of course. If it's theirs, they can modify. But other entities shouldn't be able to modify something else. That was interesting background noise. What was that?
That's my mother walking around.
The idea here is that the car itself should go to add or extend on the engine and be able to utilize the engine without being able to modify the engine directly and make the engine different, right? Things like that. It should be, so this is it very much what I think, Aaron, I think you mentioned the getters and setters. Someone else mentioned abstractions. So like it's our access modifiers and stuff like that. That's another part of this. The access modifier system where it's public enough to utilize, but not public enough to modify. All right, this one's gonna be a tricky one. I think we might not do this one, but I'll let people take a stab if they want. The Liskov substitution principle. Any ideas? did think so.
Oh geez. Oh geez.
About
What was that?
something about substitution, I don't know.
I feel like Mike, you're trying to say something, but I feel like you're far away. I don't know. Someone's trying to say something. I'm having trouble hearing them.
I just said something about substitution.
Substitution. All right. Well, I would assume that it has to do with substitution because the word substitution's in there. Let's see.
That's my
This one
best
again.
guess.
This one doesn't really have a lot giving, like there's not much given to it because it's a name and then it's a substitution principle. So it doesn't really hint a lot, unfortunately. I actually don't like the name of it. But functions like methods that use pointers or references to base classes must be able to use objects of derived classes without knowing it. And so that's kind of the idea we've done with the abstract classes interfaces. A interface or a class that uses a pointer to, like, for example, a base class, so like a car or an engine. They should be able to also use the objects of the derived class, things that are built from those, that are assigned to them, that either inherit from them, implement them, or use them without knowing that they're using an alternative version of this class. So very similar to what we did in Felicia's fruit stand. We had our product, we had fruit and drink, sorry. We had fruit and drink. And as far as our main program was concerned, it could accept either fruit or drink, and it didn't know what it had and could use them, right? And could still display them fine, utilize them fine without any issues, right? Similar concept here. That's what this is kind of about. That we can, if we use one class, we should be able to substitute a derivative class and not necessarily need to know that we're getting a derivative and be able to handle it. So that's the idea of the open and close as well, that if we have our program uses an engine and someone makes a child class of that engine, our program should be able to use that child engine with no issues. It can't take advantage of any of the other new features that child engine has, but it should be able to utilize that engine and not need to know that it isn't the original base class. Does that make sense? Cool. Next one, the interface segregation principle. Any ideas?
About keeping interfaces separate from one another.
I can see where you're getting that from. Yeah, interface segregation, good. Definitely taking advantage of the words. Any other guesses?
It's better to make it more specific to work for a specific task rather than just making it like a one for everything.
Interesting. All right. Any other guesses?
To leave it open-ended for the user or the one you're building it to,
A little louder,
I
Manny.
guess, developed. I said to leave it open-ended for another developer who's using your product to use.
All right, let's take a look. Many client-specific interfaces are better than a one general purpose interface. I think most of you guys pretty much got this. Actually, John, I think you hit it almost on the head there. That idea that you want more specific rather than one catch-all kind of things. And that's very clear here, yes. Your interfaces should be fairly focused on what you're trying to do, and it shouldn't be a one interface catch-all kind of thing. I don't have an example on the top of my head, unfortunately, but that idea, like if it's too general, then people aren't really going to use it because then you won't have access to all those more specific items. So you're going to be doing a lot of instance of situations, and you might end up not even using the interface itself because it's too broad and too general purposed. Then you're not going to be able to take advantage of those special scenarios that some of the classes have.
So I guess if you made a car interface but you included the engine class as the interface part of that car interface, started putting the car together in that one interface and have access to everything, because you won't have, you're not breaking down the interface to its individual classes. You're just, making one interface just do the whole project or so. Is
Yeah.
that kind of like it is? Yeah.
I think that sounds accurate. Yeah, it's hard to visualize the whole thing in my
It's like,
head.
I guess if we're doing
yeah.
blackjack, it's like putting the cards, what the card can do inside the deck's interface, in the decks, and what the deck can do. You don't
Yes.
have
Well,
to-
yeah. What I will say, like technically,
the deck.
what I will say is our current deck interface is not following this principle. For example, it is a very vague one interface catch-all for any type of deck. It has two methods and that's it. So I will say in this, but at the same time, in this case, it is fine for the use case. But that idea that be aware that sometimes being more specific to the classes you're dealing with is better. So if you do have one in your, the main idea here is that you shouldn't have to decide between forcing yourself to use the interface or using the class itself. And even then, if the class can use an interface, and you're realizing you're not liking that interface, maybe create a more specific user interface, a more specific lower level.
That interface should have both the standard deck interface and then an interface for the cheaters deck.
No, not that. Because we have the same behaviors for those two.
Yeah.
What I'm talking about more is when we get to other more complex decks. Like I wouldn't say Uno though, like because we don't have a reshuffle system yet. So we aren't dealing with other games where, yeah, we might have to reshuffle, or dealing with a discard deck where we're never drawing from it. We have trying to think of the other things. Like, so in this deck class, we have no way of adding cards to it, right? Now in the games we're playing, that's not a problem. But if we ever want a discard deck or a graveyard deck, for those of you who play games, the card games, but for like, what is the game I'm thinking of that has a discard pile? Or even then, I don't know if it's called a discard pile per se, but yeah, you have the Crazy Eights where you have the center thing. Solitaire, as you draw cards, supposed to draw out 3. Yu-Gi-Oh. I knew that was coming. As you in the standard game of Solitaire, you're supposed to draw 3 cards, and then those 3 cards go into the discard, and then you draw 3 cards. Once your draw deck goes away, you just flip back over the discard back into the draw pile. It becomes your draw pile. And that's kind of that idea. Our current decks can't handle that stuff right now. Our current deck interface can't handle those things. And so our deck is very much a one general purpose interface. It's one general purpose we have right here. And so making sure as you get into more complex systems, more complex games, having more specific interfaces can be useful. And the reason why is maybe like, well, why not just use the class itself? Interfaces help with the open close principle. Interfaces you can access, you can extend, but you cannot modify through the interface. Remember that. Interface just allows for methods, not for fields and not for things like that. And you can only you can only get the method name. The implementation of that is defined by the class. You cannot modify in any way how that class does it. So interfaces are very key to the open close principle. I'm going to try to find more examples of this. I wasn't planning to do this today, so I didn't pull any up for this, but last one, which I think I may have just given it to you, but yeah, dependency inversion principle. Any guesses on that? So one of us said a key phrase or a term of art that I said it matters to one of these, and we haven't talked about that yet. So there's your hint.
Coupling.
Has to do with coupling, yes. Any guesses on this?
Sorry, could you repeat the question?
Any just guesses on what the dependency inversion principle is?
To not be coupled to all things that you don't need to use.
All right. So I don't give any hints yet, whether or not you're right or wrong. So anyone else want to take a guess?
That you want it to depend on one thing instead of another thing.
All right. Any other ideas?
I should know this and I forgot it.
Okay. Any others? One more. I usually like 3 out of because of the number of people we have.
I'm thinking like if you had an interface with 3 methods in it, and then a class that's implementing that interface, it's vaguely touching on those methods that are in the interface. It's not like bound to a defined method. It's just a declared method. And it's up to that class to define it. So it's kind of loose.
Interesting. All right. Good approaches. So this one is dependent upon distractions, not concretions. And the best way to exemplify this, and the most common picture you'll see when someone talks about this, is the outlet. The idea that things that work with each other are not hard coupled together, they aren't bound together, that they can be hot swapped, that a system that uses some sort of interface can easily swap between other interfaces that are similar in nature. that we can easily swap things out and make those easy changes. That if we want to use a newer version of something, we can easily swap it into that newer version. Some of the ways we've kind of broken that and not followed that is when we have specific data types, or we're sending a specific class as a parameter to a method in another class. Those two classes now become hardwired to each other, and then they don't work anymore. One of our first consoles we ever, like console classes we ever created, was very much meant for that item. If you really think about it, the console class we created for our fruit stand is hardly coupled to it. It's only going to be useful there. We can't bring that console anywhere else. However, the console we currently have in our Blackjack game is very uncoupled. It just has the get int and get string methods. And a goal here is to actually make sure that that console stays uncoupled, that we can be able to bring that console to any other application at the same time, be able to put a different console class in that is different in its behavior without the main game being confused. What's that?
This is very generic.
Yeah, the idea is to keep it very abstract, the idea. Yeah. So generic is another way of using it. Yeah. The goal here is we want to depend upon the abstractions and not making sure that they're hard coded together. We're not writing classes for specific use cases unless we have to.
Like so making an input class and then adding it to other classes and making them totally have to be bound to each other.
This one had the doesn't have the pictures. I can't remember. No, it didn't. But there's a bunch of items here that can help understand that. So class square, they have the length thing, construct length, very, very simple. Very small, very, very small methods is the idea here. So your methods want to stay small to this point. Like even just the sum calculator output right here that they have. Look at how many methods they have. Now they're using a function-based language, not JavaScript, Java, so that's why they use the word term function, not like us. But I think they're actually using JavaScript now that I think about it. Maybe. I don't know. They look similar. But we have the items here. What's that? Is it C#?
They're using a class.
Yeah, JavaScript has classes.
And protect
Oh, I didn't know that.
Yep.
Looks like jQuery in JavaScript.
Could be that. Something like that. I don't know. But I do see the $sign. I think what you're saying. But yeah. So here we have we have several methods: constructor, JSON, HTML. And so there, even though we could do all of these in a single method, right? We could do all of these in a single method.
Yeah.
The idea is to keep them nice and separate. So anytime it's like, oh, I want to change how the HTML looks, I come in and just modify this method. I don't touch any of the others. The others are left alone. I want to change how the JSON data is formatted or coded. Well, we come in here and we modify this. We don't touch the HTML. We don't touch the function. So depending on what I want to do, I can go to that specific action, that specific function or method and change that information there, right? And that's one of the main concepts of the single principle thing, single responsibility principle.
Single responsibility principle.
That one, yeah, SRP. Open closed. Objects entity should be open for extension, but closed for modification. The idea of protected. So area calculator focus on some methods. So some, we have all this information, but we can, yeah, here we go. Consider a scenario where the user would like the sum of additional shapes like triangles, pentagons, hexagons, etc. You would have to constantly edit this file and add more if-else blocks, right, to handle those. So we have those here. So if the shape is a square, if the shape is a circle, if the shape is a hexagon, so this is not really defined around that. If you make this sum method better, is to remove the logic to calculate the area of each shape out of the area calculator class method and attach to each shape's class. So you have the class square, area, class circle, area. This is the idea of the, we shouldn't have to keep modifying this item here. So.
So they're just in separate classes, right? Mm-hmm. Circle, square.
This would be a good one to look up. So I would definitely look up this one. I can share this link. So this is actually a really good one because it gives you the examples. I'm actually glad I found this one. So I'll give you that link.
Copy link address.
There it is. They moved it on me. The main focus ones I wanted you guys to focus on mostly though was that single principle one and that decoupling thing is really the two most important that I get a lot of, that tend to get asked a lot about. So the first and the fifth one are the most important. You'll get asked about a lot, and they care about those the most.
I'm sorry, which one?
The single responsibility principle. That one is a huge one that's really, really important. And the D, which is the dependency inversion principle. Those two that they care the most about. The other ones are definitely looked at, but I noticed a lot of times when we see the interview questions for companies, it's one of these two usually. They talk about this stuff. So I want to give you that.
And they also ask the four pillars of OOP.
Yep, you got those. Which again, I hope you guys can remember. Haven't forgotten those because those will be on a quiz coming up soon. Not really a quiz, but just a test that I will be asking you questions on. So that is in the interview, 100%. There was one that I liked. There was a site that I had. I gotta find see if I had that link to it somewhere because I had one that I kept using. It's probably in my Google Drive. It had meme-like pictures, which can help us to remember things better. We have like funny pictures and stuff that at least some of us that can help you remember things, but no, I'm not seeing it here. So I have to find that site later. Anyway. Yeah, solid principles are useful. Mostly again, they're gonna take that code and turn you from a person who's developing a very obviously student level code and take you to look like you're already a hardened developer. And that's really what we want you to look like in the interview. Are you 100% students that just graduated? Of course. But do you have to look like that? Not at all. And that's, again, one of the goals of Career Devs is to make sure you guys pop out of here looking like and feeling like you're pretty much an established developer that just needs the work experience. That's all you're missing. And that with the skill level you have and the ability you have right now, we just got to put you in the job and you'll exceed. You'll succeed. So that's what you want to come off as to the interviewers. And so that's where my concept comes into play is I want to make sure you know these principles. Since now I'm feeling pretty confident you guys kind of know how to at least make code work in Java. Now I want to clean that code up a bit and make it more professional looking. And so I want you guys to try to consider these as you build your projects with the card games in a couple weeks. So you want to start really practicing that concept, especially the really big one I want all you to focus this time though. And this one I think I am going to hold you to. So the OLID, I'm not going to hold you to for the grading. The S, I think I'm going to hold you to in the grading of this time because that's something I've been pushing for a while. This idea of methods should be short, simple, and sweet, and have one focus. And so I want you guys to enforce the S principle in the SRP in your project that you're going to do next up. So take that time to make sure you do at some point, pull your methods apart, objectify the hell out of your code, make them classes, pull them apart, and do what you can on that. Who just came in? Oh, Radiant. Did you lose him at some point? Oh, we did. I didn't realize you dropped. Not bad. So, welcome back. Cool.
Are there any good books that you would recommend on solid programming principles?
Ooh, solid for books. I don't know about solid books for solid.
Or maybe like a YouTube channel or tutorial.
Not off the top of my head. Like I said, I wasn't planning to do this today, so I didn't pull up my notes on this, but it just fit really nicely with what you guys did yesterday that I wanted to touch base on it quick now.
That's right. Jim just posted one in the chat.
Thank you, Jim. That works.
How did you personally achieve
basically
that using that consistently, adhering to the principle?
For me, it just I guess it's not fair because for me, it just when I read these, they kind of made sense to me.
Okay.
Logically, they were like, oh, I like that idea of just making each method one by one. And so for me, I think it was an article similar to this. Like, again, I tried to find the one that I used to understand the solid principles, and I couldn't find it with these. Not one of the top ones anymore. I also looked it up. I think last year was one of the first time I looked it. So a year on the internet is a long time.
Sure is.
So, things pivot a lot after a year. So the site I use is not there on the top of Google anymore. It kind of sucks. But
you should rate everyone's code to see how solid they are.
There you go.
It's good. It's really solid.
I'm just gonna put it on the whiteboard here.
There you go. Good. Have the whiteboard. Like I said, that's why I got this thing for you guys. I can draw better, and I'm also using it as my whiteboard nowadays. So Miro, by the way, is good. Elaine.
Oh, Miro is good.
Yeah, I approve of it. It worked. I used it over the weekend. So, but
the reason why I say it's you because I put it in Slack. I added to Slack. Miro.
Cool. Ah, cool. Yeah.
and,
Nice.
and it like hooked up to you.
Oh, go figure. But yeah, no, for me, yeah, the main way I got into Solid was one, I had redone the looking online, but then at the same time, again, part of how I learned Java, I will be very clear with you guys, I didn't finish any of the Java curriculum that you guys have actually taken. I reviewed them and I evaluated them and I popped around to make sure that I liked their lessons. I learned Java through grading assignments. So like the previous cohorts that did Java, I would have to go through and review the assignments, and I would look at the code and like, is this gonna work? And so I test and like, oh, that does work. Cool. I now know how this works in Java. So I learned Java through osmosis through the previous cohorts. So that's something that you'll eventually be able to do as you learn more coding languages. You won't necessarily need to take a lesson to learn something. You can just look at other code and understand the logic of how just computer programming works and how it's all based on a flow of information and a flow of data, that you'll be able to look at other languages and start learning the syntax through that and not necessarily take a class on it to learn it.
It's interesting you say that, because like a lot of the things that I've learned from Java, at least, is like IntelliJ being like, hey, did you know you can do this in this way, which is shorter and cleaner?
Yep.
IntelliJ is awesome for that.
Yeah, and
that's not something it always used to have, I swear, because that's what's new to me too. So I don't know what version they put that out in, but it's a very good item to add.
The great thing is that it's not just doing it for you. It's like you complete something, and then it's like you could do this instead, and it's way cleaner.
Yeah, it's a really nice feature that they added. I don't know when they added it, but it's impressive.
Yeah, and the drop down also gives you information of why sometimes, like why it's better and etc.
That article I sent, that the list was a Liskov substitution principle. It says the principle suggests that, quote, the parent class should be easily substituted with their child classes without blowing up the application.
Yeah. In other words, again, you shouldn't have to, if you're doing a lot of type ofs or instance ofs, you shouldn't be using the parent class in the system. You should be using the direct class. If you're constantly checking the type of the class, then the parent class is a useless item. So the idea is that if you're using, if your systems are set up right and you're using things right, you should be able to use the parent class instead and not break everything. If that's a good kind of setup, that's a good configuration. Right, yeah, that way you can substitute things. And that way you can also substitute like a cousin or sibling. So again, if I'm coding something and I have the drink, and currently I'm starting with a drink, but then I want to use the fruit instead, I want to do the same code with fruit, I shouldn't have to rewrite my code to specially handle fruit because they're both products. I should be able to just substitute the drink with the fruit and the code should work fine and not blow up. That's that concept there. That if the classes are truly related, they should be interchangeable. Sound good?
So that's like when we were instantiating a product, and it would be product, whatever, soy boy,
right?
New drink instead of, and then we could just do the fruit.
Exactly. We would still treat it though as a product. We didn't treat it like a drink. We treated it like a product. We would instantiate a drink, but we would treat it like a product. And that one, like that little exercise we did with the Felicia's fruit stand with that one, that was a really great example of that Liskov substitution principle, because we were able to use the product everywhere and we didn't have to use any class specific items. We didn't, and I don't actually remember if we ever really had to do any sort of like instance of things, only with the create or adding one to the list on our user interface system, just to make sure we ask the right questions. That was the only time we had to then differentiate what are we creating, because that's part of the user interface system, not really part of the logic. So that project is a great example of that Liskov substitution principle. We use product everywhere. We didn't have to do any sort of specific child class, and anytime they could be one or the other. And if we ever did bring in another type of product class, like meat or dairy or something or anything else, it should work with all that existing code already. And we shouldn't have to change anything. The only thing we'd have to add is just to that console to make sure we ask the right questions. But even then, we could find a way to update that system to make sure that we would just add a product and it would be able to pull from the product what questions it would ask, what data does it need, right? And that we could still update that console that adds a product to make sure that we dynamically ask the questions. We don't have to have a list or any way of sort of like predefining it. So we could still improve on that to really make sure that the whole thing is following list-conf. So there's still one section that isn't following list-conf, but the rest of it is. So cool stuff. Yeah, I'm actually, because I was not intent. What I'm actually kind of proud of is that I wasn't trying to do that in that one, but it just worked out that way.
Well, it's always good to know, though. We
Yeah.
need to know it.
Well, the good thing is that once you start following these items and you start practicing them, they'll make sense. They'll fit, and you'll be like, okay, I see why we're doing this. And this is actually, you'll realize it is a good way to write the code. There is, do we just lose someone again? Iridian? Did we lose Iridian again? I wonder if his internet's acting up. That's fun. Yeah, you'll start seeing the benefits of, or at least understanding the benefits. Maybe you won't really see them per se, like in action, but they'll make sense. And they're like, okay, I can see why this looks nicer, or is cleaner, or is better code. And that's what's really cool about these things. That as I practiced them myself, I did start finding like, okay, yeah, this makes sense. I can see why it's recommended to do this, because it makes my code more usable, more reusable. It just seems more structured and more professional, right? So as you go through these will make more sense. Like I said, my main thing I'm going to challenge you guys later is that I want you to really focus on the S in the next project. We're going to follow more of these later on as we get into Bootstrap, the Spring Boot and stuff like that. These are going to make more sense then, because you're going to see that just built into the Spring Boot stuff. So Spring Boot themselves follow solid principles. So cool. With that being said, let's get back to Blackjack, because we've already been delaying enough on that. We have a bunch of Java to catch up on, because we're a day behind now. So let's pull up IntelliJ. Let's pull up our plan of attack. And we come back. Yeah, you made it back in. Nice. Move that out of the way. Internet issues today? I don't know if he's connected yet. Iridian, is your internet acting up?
Yeah.
Yeah, I can see that. I'm like, oh, he keeps dropping. That sucks.
Yeah. And I'm also trying to use a tablet as a second monitor, so it keeps on bugging everything.
All right. There's Blackjack plan of attack. Drag that over. All right. All right. So we're gonna take a look at this. So I gave you the challenge to try and attempt to build the actor stuff over the weekend. How did that feel, building the actor class? Did you feel like there was still a good amount of stuff that you didn't have yet, or that it was a little weird to make the actor class? We debated whether to do the hand or the actor first. We chose actor because there was this one rule of thumb that we were using, that the hand class contains a player. And so it's kind of hard to make the hand if we don't already have this, right? That was the reasoning we had, because that was the reasoning we used before. Would anyone have to, I'm just curious and wondering, does anyone disagree that we should have done that way? Or could we have done the hand without the player to start? Or did that rule of, or that guide saying, hey, hand has players, so let's build player first, still fall through, or still work?
I kind of moved away from, I tried to keep the hand in the play, like the player control, no, the hand controlling the player. I think I might have moved away from it a little bit, though, in my code.
Very possible. What is the, so here's something, like I said, I'm very curious what you guys, I'm always very curious to see what you guys done with it, and it's definitely doable. The trick here is that there would have been a lot of assumptions to be made, and the biggest issue here is that there would have been no way to really test this thing, because we can't test anything without a hand, can we? We can definitely do the balance and the bet, but like get action requires the hand, right? We probably need the hand to be able to display things and ask the player what they want to do. Like we can always ask them without displaying the hand, which seems a little weird, right? And we know that the dealer makes a decision based on what their hand is, right? And so really there is no definite guarantee which one to go first, hand or actor. Either one's fine. What I can do today is I can showcase kind of a way to kind of, we could try to build the hand, the actor a little bit, but then at some point realize, okay, I can't build this without the hand and go to the hand, or we can just go hand first. And this one, and I can show you why this one, we could do this without this. And that's why I want to make sure we understand that. Well, in previous lessons, there are these rules or these kind of guides that we can use to say, well, because of this, let's do this. they are not always something that you need to set in stone, and you can still bend those rules and bend those guys and understand that not every single situation is going to follow the same rules and situations. Just because a class is composed of another class, that doesn't necessarily mean that that class has to go first. You can also ask yourself, do I need a player in order to use a hand in the game Blackjack? Or can I potentially play Blackjack by myself? Could you? Could you play Blackjack solo, technically?
Yes.
Yeah, we could, couldn't we?
Yeah, just against the dealer.
Not even that, right? You could just try to get as high as you can without hitting 21, right?
That's true.
Yeah, and I feel like there's actually like a betting system for that too. Like if, depending on how close you get to 21, you get your bet. I think 17 is a push, 18 you get a 0.1 payout, 19.2, 20 a 0.5, and at 21 you get a 2. You get your pay. You get your bet back. So I feel like that's been a thing. And Blackjack is 1.4. It gets a 2. It gets a 2.5 technically, like the 0.5 extra. So, and actually, no, I think that's not quite right. Right? No, I'm a little off. What was it like? Yeah, the 17, 18, and 19 give you partial bet back. 20 and 21 can either give you your bet or give you more than your bet, and then a hard Blackjack gives you the extra bonus. So something like that. I've seen that. It was a PlayStation 2 or 3 game. It might have been Persona that did it. Wow. Okay, I'm gonna avoid this conversation. So there's a game that done it though. That's all I'm gonna say. A game had you play Blackjack by yourself with no dealer, and depending on how close you got to 21, you would actually get paid for that in like tokens and stuff. So it was weird. I was like, this is different, but totally doable. So let's do that actually. Let's actually show how we can do that now. My biggest focus on this though was I did want you guys to try to like prep to start building these items, because again, our focus is interfaces. You guys are learning interfaces. So that's why I give you guys this one, because we had the whole weekend. The hand is not that difficult to build. We're still not sure these go here, so we're going to hold off on these. We definitely are going to do these first. And if we do these, we still might do those. But anyway, let's do these. Let's start with the top. Let's go down the line. All right. So card game. New Java class. Hand. So first thing I want to mention though, I thought I already done this. Cancel. Also, I'm actually going to undo that. Hold on. Don't do it on your own. I just want to do something quick first. Hold on. I forgot to mention I want to do this. For a second. Terminal. Am I on main? I'm not. I am on main, but the stuff that needs to get pushed. Okay. I don't know what it is. It's probably what I just did, but. Get checkout. See. This is the common thing you want to do. Branch to the feature you're adding. So we're going to add the hand system. All right. Now we're going to build a hand. All right. So new Java class hand. Here's my drink. Itching my throat. Here. Now looking at this, do any of these things feel like they don't really mix? Anything, do these feel like they all fit together, or do we need to start separating them?
And should be separated.
Jim.
They should be separated.
All right. What should go where? Give me a package name.
I would say deck.
All right. So package 1, we'll call it deck. And what goes in deck?
Deck, rig deck, standard deck.
Move them all at the same time to save on the refactoring. Anything else?
I'd be debating about card, but it's weird because card could be its own package, but it's just one class.
Well, here's the question I guess I could.
You could just put it in there just because it's only one class. I mean, and technically you should be having their own separate packages, so it would be much easier to look through. Because
Hold on.
Card for card class, but
Oh, I can give you a very simple answer to this. So thinking back to our solid principles and our D, how hardly coupled is our deck to the card class?
it's
Hardly coupled. Really,
We
really.
need this card class. Our system is using this specific card class. So yes, we do need this in. Now, it could be beneficial if we created a card interface, then we don't have to bring the card class in. We can leave the card interface and make a card package that can have different cards. So that's another reason for the interface, by the way. As long as the card that we use can follow the card interface, then we can have that soft coupling. That would be a softer coupling. These two classes are definitely hard coded together. They are hardly coupled. So this deck relies on this card class. It needs this class in order to function. Like I said, that's another concept of the D principle, and that's why I don't worry about. I'm not making you guys focus on that later, because the D principle involves a lot more interfaces and a lot more abstract classes. It relies heavily on those items more. So is the I one as well, the I principle as well. Those two both are telling you that your code should have more interfaces and more abstract classes to reduce the amount of coupling your systems have, so that they don't have to go with them. Because of our hard coupling, we're going to bring the card into the deck class because they do rely on each other aggressively. So we will bring that there. All right, next package. What are we going to do this package then? I'm assuming that the next one is separate
now. Well, actors or players, because
we're not dealing with that yet.
Right
we have the hand.
That would be the other one, but it would be a hand class. But I don't know, because that's going to rely on the deck and cloud classes too.
All right, so we have let's take a look at these. Hold on. I'm going to go over here. So we have these guys in the deck class. I'm going to mark them with a that. So now how do we want to organize things next? So I'm going to get rid of this for a second. I'm going to move some of these away from each other so they're not side by side right now. So I'm going to move you over here, move you over here, move you over here. All right, so give me a letter name and where I should put it if I want to move it next to something where they should be connected to each other, and potentially in the same class or the same package.
Hand and tables.
So you're saying
stand.
So Jim, you're saying hand should be next to table and they should be connected.
Well, because table has hands,
Mm-hmm.
and the only reason why I would say that, because they're kind of like associated, but
Yeah.
you know, that's just I'm just going by what the.
Any other ideas? Oops, sorry, David, you're being called. I'm gonna mute him so that no one has to deal with that. He should be able to do that on his own.
That's my first guess,
right.
and I can't even see game because it's so far over. But let me.
I can move
It's
it a little
okay.
bit.
Now I can see it. Just have to move my little box over.
It's okay. I forgot that he has at the window there with the cameras.
Yeah. I just closed it. I got it like
Got it.
small. I can see it. So yeah, I don't know.
I could see that. I could see that where our hand and table could be put together. Here's an interesting thing I want to show for this one to kind of help with that whole item we just talked about a little bit. I can move actor here, but have our actors be in its own package. So we can have the actor package, but have the actor interface be part of this group. And maybe even have the game be part of that group. And that way, we can bring in any package that those items implement a actor class, an actor interface. And it doesn't necessarily need to be this actor interface. It can be a different actor interface for in all technicality. These are going to pull this one for our purpose, but what we can always do is a packaging system is say, hey, when we bring in this item, you just have to import an actor class, an actor interface into this. So this is going to import the I actor from this package. So these three guys here are all going to import or these two is what we're going to build first, are all going to import the I actor from this package. But if we were to, let's say again, we were to upload this or give this to someone else, all they would have to do is just change that import method on these to an actor method of their own or an actor interface of their own. That makes sense? So that would make it a little more swappable. And something we could have done with our cards and deck that we would have had but again, we don't have a card interface or card abstract class. That's why cards have been hardwired. But this will show that kind of separation. So we can have just an actor package, and we could probably call this the, we'll call this a blackjack package, right?
Yeah, because you could have
a game package, I guess, whatever we want to call it.
Yeah, you could have an animal class and you could still use the I actor class interface for the animal class and have a bunch of animals play.
Yeah, technically.
Yeah,
Yep.
exactly.
Yep. Technically, we could do that. Interested to see them play, but sure. That for all intents and purposes is kind of the idea I'm going for, 100%. And this way, again, you could also bring in other packages. So one of you guys could even create a AI actor package that has just a bunch of different types of AI players for blackjack that follow different strategies in different formats. And then you just bring that package in, make sure the import brings in the actor interface that's required, and then it's all set to go. So the idea again is that one single line change, and that's how hot swappable it is. So make sure that you mark the right interface. Cool. Awesome. So let's go ahead and this is kind of how we're going to package these items up. So our first item I'm going to create both packages, even though we're not going to fill one of them up, but we will create both of them. So not refactor, new package. So what do we want to do this one? So we have company card games. So this is probably going to be the blackjack package. This stuff is very blackjack specific. Blackjack. And then one more package. That's going to be the actor. Trying to make sure I keep the title case out of my packages. So I was usually bad with that.
You got Decus now.
I do. You're right. Refactor, rename. There we go. It's that. Cool. So hand class is going to go into our blackjack package. From here, now we're going to create our hand. So looking back at our, so actually I'm pretty sure I shared with you guys. Did I share this with you? Actually, I actually forgot if I don't think I put this in Classroom. Dang it. Copy link. Classroom. That way you guys have access to this too. You definitely want to have access to this. 12. Let's work. E8 material. I need to get some oil for that door. You guys hear that, right? Sounds loud to me. No? Oh, good. Okay. I've always thought this thing can catch a decent amount of noise, and I hear there's a door in my apartment that is just very, very squeaky.
You probably heard it, though, but it wasn't that loud.
Okay, good. I'm just worried because it is recording, and I'm like, I don't need those sounds on the recording. I do have a can of WD-40 somewhere. I just gotta spray it. Let's see, title. This is one of the blackjack. Get a material. That. Topic. Material. There we go. Cool. So you guys can pull that up. That way I can refer to you guys and these screen swipes left and right. It can be a little dizzying sometimes. So what does our hand class need based on our plan of attack? Jim, are you actually stepping away this time, or did you just leave that on again?
Yeah, I am. I was just kind of just watching for a few seconds.
I was just noticing you
Walk
had it
off.
on again. Like I know you sometimes accidentally leave it. So I wasn't sure.
No, I was planning to walk off in a second, but I just wanted
Okay.
to get out of this. Well, but you know what? Let me not
I
leave
just
it like
I
that.
saw you lean back like you were getting comfy. I'm like, I don't think he's going anywhere.
No, I was just getting myself to go, but I was just,
Gotcha.
I'll just wait until this comes up.
All right, people, come on. What do we need?
I'm staying out of this, so you guys can figure it out.
You built.
Well,
one.
it should be able to hold the cards.
That's that first thing in our plan of attack, right? Yeah, the cards. So we're gonna do, and again, we're gonna start them all private. Remember that. We want to start with that kind of isolation, that abstraction process, and keeping things very isolated. Remember, we're gonna depend on abstraction, not concretion. So private is helping to make things private, to make things abstract. So private list. Use our list. New list of cards. Again, it's gonna tell me I need to import. Card. That's why it's yelling at me.
Yeah, you have to go to the back.
Yay. David, you're gonna mute yourself.
Sorry.
All good. Cards. And we're just gonna go ahead and just initialize this to an empty hand to start.
I'm sorry, you talking to me?
Yeah, just you. You're good now. You muted. You're good. Yeah, you just gotta give them on a background noise in your place right now. So
Yeah, sorry.
that happens. It's all right. Just letting you know. You're good.
Should be called hand and not cards.
What?
Should be called hand and not card.
I tend to like that because then that usually becomes hand.
Oh, yeah.
Usually. So I usually don't like that. So this is hand.cards. That way we can have other properties or the fields of the hand that are, so that I don't like having a property or a field be the name of the class.
Yeah, but then it's
Again, that's
kind of
just a rule I have.
Yeah, I know. I mean, I understand where you're coming from
Yeah.
completely. But the whole other thing too is like cards. What are cards? I mean, it's just a bunch of cards. Is it not my hand?
Well, that's kind of thing. My hand is full of cards, right? You would say that. You would say my hand has a hand. You would say my hand is full of cards.
Well, I would say,
So
yeah.
that's how I
my
look at
hand,
it.
I have Cards. Yeah.
Like this is my hand and these are the cards in my hand, right?
Yeah.
So that's kind of my rule, my reasoning for it. So where again, your reasoning isn't necessarily wrong. It's just this is kind of something I found, and for me, I hate seeing, because a lot of times you'll name the variable that holds something the name of the field too. So it's very common. We'll probably, whenever we're dealing with a hand for a turn, because each turn is a hand, we're probably going to refer to that active hand as the hand, and then I'm going to do hand.hand to get the cards, and that doesn't scream to me plural, right? Cards for me says this is plural, and it's also telling me that each individual item is a card. And so that's why I like these as my names for them, because they are very kind of like almost telling me exactly what it is. That's why I like it. So, and it's something I've seen very, very helpful. Of course, like I said, with anything, just go based on what the company does. The company is okay with it, and go with it. What else do we need in our hand? Based on the plan of attack.
Bet.
Yeah, the bet on the card, right? All right. What data type are we going to do the bet for? What is that, Mike? Yep, remember, avoid those decimals. And bet.
That should be lowercase.
Ah, dang it. Go. Zero that out. Bet equals 0. Any other data types for now? Look. That's our hand right here.
Yeah.
We do want player, so I'm going to put it as a comment for the moment since player doesn't exist. So I'm going to do private player. And so again, this is kind of my example, like why I would never put like a list of player of the same name if that's what it is, because yeah, I'm going to do player dot something. So and so later on in the table, I'm going to do hands. I'm going to pull the hand out and I'm going to call the hand a hand. So then I'm going to do hand dot hand. Hand equals hand dot hand. So it's hand is gonna get very annoying to me very fast if I do that. Player, and we're just gonna do that for the moment. that was going to, that's probably going to be part of the constructor. All right. So with this though, do we need a hand constructor yet? Technically. Any guesses from anyone else? I'm getting a no from Jim. Any other ideas?
I say no, because we could just deal 5 cards into the list and have a hand.
One second, though, this is on now. 1 second.